Advanced Notes, Lesson 10, Interpreting Graphs of Proportional Relationships. Tonight I started filling in some of the notes for you, so hopefully this will be a little bit shorter lesson than last night. So have Lesson 10 out. The key ideas, what we're going to concentrate on, what the points 0, 0, and 1 are mean on the graph of a proportional relationship. So first example, Grandma's Special Chocolate Chip Cookie Recipe, which yields 4 dozen cookies, calls for 3 cups of flour. So if I have 3 cups of flour and all the other ingredients, I can make 4 dozen cookies. Using this information, complete this very large chart here that has 6 sections. I started some of it for us. A table. Create a chart comparing the amount of flour used to the amount of cookies. Well, it says if she has 3 cups of flour, she can get 4 dozen cookies. If I double that, I would have 6 cups of flour, would give me 8 dozen cookies. Doubling again, which I could do, doubling again, or taking 3 and multiplying it by 4, I would get 12 cups of flour. Doubling my cookies, I would get 16 dozen cookies, and 4 times 4 is 16. Is the number of cookies proportional to the amount of flour used? Yes. There is a constant here. There is a constant unit rate. There is one. Because if I take flour times 4/3, it will give me cookies. So K times X, my constant 4/3 times my flour, X, gives me my Y, or Y equals KX. I can turn that around. Cookies is equal to 4/3 times flour, so Y equals KX. The constant here, is there a constant of proportionality? Yes, it's 4/3. What is the unit rate and what is the meaning in the context of this problem? Well, I know that my Y divided by my X is 4 divided by 3. What does it mean as a unit rate? Well, that's not a 1 on the bottom. If I wanted this to be, what is it for 1 cup of flour, I could get that if I divide both parts of this fraction by 3. I get that for every 4/3 dozen cookies, I need 1 cup of flour. This is cookies. For every 1 1/3 dozen cookies, I need 1 cup of flour. So what does the meaning of the context? That's exactly what it means. So for every 4/3, or if I reduce that to 1 1/3 dozen cookies per will yield out of per 1 cup of flour. The fourth section in the graph says, graph, model the relationship on a graph. And I already started labeling it for us. Flour is our X. The cookies that we can make depends on how much flour we have. How many dozen cookies depends on the flour. So the cookies is the Y, the dependent variable. And if I start plotting the points that I have in my table, for 3 cups of flour, I will get 4 dozen cookies. For 6 cups of flour, I get 8 dozen cookies. For 12 cups of flour, I get 16 dozen cookies. Hard to do this on the smartboard. Do they look like they're lining up in a straight line? You know what? I could find another point here. For 9 cups of flour, I would get 12 dozen cookies. 9, 12. I know that's another point on here. Does the graph show 2 quantities being proportional to each other? Yes, it does. I just said that. It's a straight line that passes through the origin. The points lie in a straight line. that passes through, this is how you spell through, for those of you that have been spelling it differently, through the origin. Has to have both of those things. Yes, if I connected these in a straight line using my tool here that gives me a straight line, it would go through the origin, and these are lining up in a straight line, those points. Write an equation that can be used to represent the relationship. Well, that's what we did in lesson 8 and 9. What is the equation? The equation is y equals my constant of proportionality, 4/3, times my x. Y equals 4/3 x. Or I could use the letters of this problem. Oh, D is for dozens of cookies. Well, that's the y. D equals 4/3, and flour, cups of flour, is my x. So dozens of cookies is equal to 4/3 times the flour. Example 2 here says, below is a graph modeling the amount of sugar required to make grandma's chocolate chip cookies. Yes, baking is a very proportional life skill that you're going to have. This looks like a proportional graph to me. Record the coordinates of flour of the points from the graph in a table. Record the coordinates of flour? No, that's not right. Record the coordinates of sugar to cookies. Sugar, it's sugar. Whoops, little typo there, New York State. Sugar. Record the coordinates of sugar of the points from the graph in a table. What do these ordered value pairs mean or represent? Well, one of the points that I see here, it's kind of like in a box here, this first point. That's the point to 0, 0. What does it mean in the context of the problem? What do these ordered value pairs represent? Well, it means 0 cups of sugar, not flour, 0 cups of sugar makes 0 dozen cookies. Well, if you don't have any sugar, you can't make the cookies. Makes 0 dozen cookies. And you do have to answer it with both zeros in the sentence. 0 cups of flour makes 0 dozen cookies. Well, the next point on this graph, go over 2, so that's the x value 2 and the y value 3. So the ordered pair or the coordinates is 2, 3. So 2 cups of sugar. 2 cups of sugar makes 3 dozen cookies. The next point on the graph, over 4 and up to 6. So 4, 6, the ordered pair or the coordinate pair, 4, 6 means 4. Now I'm going to shortcut here. Cups of sugar makes 6 dozen cookies. What's some more ordered pairs that I see here? I see the ordered pair 8, up 8, over 8, and up 12. So I see the ordered pair 8, 12 also, which means 8 cups of sugar makes 12 dozen cookies. Well, there's more points on this graph. One more says 12 cups of sugar makes 18 dozen cookies. So 12 cups of sugar makes 18 dozen cookies. That's what it represents. Ran out of space, so you can just listen. You don't have to write it. And the last one is 16 cups of sugar. 16 cups of sugar makes 24 dozen cookies. So you don't have to write that all out, but please do copy all 6 of the ordered pairs. It does say record the coordinates of the points of sugar here. So I did do all 6 points from the graph. Letter B, Grammy has 1 remaining cup of sugar. How many dozen cookies will she be able to bake? Plot the point on the graph above. Well, 1 cup of sugar, this is what's called the unit rate. 1 cup of sugar. When x is 1, here's when x is 1, right here, this first little line there. How many cups of, or how many dozen cookies can she make with 1 cup of sugar? She can make 1.5 dozen cookies with 1 cup of sugar. I read that point there. When x is 1, the y value is 1.5. When x is 1, this y value here is 1.5. So when x is 1, that's the unit rate. It's called 1 comma r, meaning r for rate. 1r, that's one of the key points that we're going to talk about from the beginning of the lesson. So 1.5, that's the unit rate. She can make 1.5 dozen cookies per cup of sugar. That's the unit rate. 1.5 dozen cookies per 1 cup of sugar. How many dozen cookies can Grandma make if she has no sugar? Well, we already answered that. 0 cups of sugar makes, we answered that right here, 0 dozen cookies. What do we call that point? It's the point 0, 0. It's called the origin. So that's the second key point that we're going to talk about with proportional graphs. We know it has to go through the origin. It also has to go through the unit rate, meaning that there's a constant, the constant of proportionality. And then the graph will be in a straight line. So it has to have 1r on the graph. The next example, example 1. The graph below shows the amount of time a person can shower with a certain amount of water. Can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water? How do you know? Well, explain how I know. Yes, the points, same way we've answered this before. The points lie in a straight line. You got to say straight line. In a straight line, and pass through the origin. Or a line, a straight line that passes through the origin. I could say it that way too, doesn't matter. Oh, what is that? I don't want that. Go away. Must have hit something. That smartboard's being weird. That passes through the origin. And this graph does that. It is a straight line and it passes through the origin right there. How long can a person shower with 15 gallons of water and with 60 gallons of water? Okay, 5, 10, 15, they're counting on the x-axis here. So 15 gallons of water, that's the x. Oh, I think they can shower for 5 minutes. So 15 gallons, I'm going to abbreviate this, gives you 15 minutes. Oh, sorry, 5 minutes. 15 gallons gives you 5 minutes. 60 gallons looks like it's going to give you 20 minutes. So how to read points from a graph. 60 gallons equals 20 minutes, or we'll give you 20 minutes. Gives you 20 minutes, not really equals. We'll say gives you. What are the coordinates of point A? So coordinates of point A, go over the x-axis first. So 25, 30, going up to 30, going over to 30, and up to 10. Going over to 30 and up to 10. So the coordinates are 30, x first, y second, 10. Describe point A in the context of the problem. So 30, gallons of water, that comes first, X, it is the Y, it's the X value, 30 gallons of water, 30 gallons of water is a 10-minute shower, according to this proportional relationship. Can you use the graph to identify the unit rate? Well, yes. We've got to find the unit rate, 1R. 1R is on the graph. Since it is proportional. The unit rate has to be on there. It is proportional. So can you use the graph to identify the unit rate? Well, it's hard to read when there's just 1 gallon, because this remember is 5 gallons, this first line. So pick one of the points. Okay, I'm going to pick this first point that we said here, which was 15 gallons gives you, right? 15 gallons gives you 5 minutes. So I'm going to pick the point 15 gallons giving me 15 gallons giving me, so the point 15.5. Now remember, 15 is the X, Y is the 5. 15 gallons give me 5 minutes. So if I do Y over X, that's the unit rate. It's always Y over X. It's, it's 5 over 15. Well, the unit rate says, what is it for 1? What is it for 1? That unit rate says, what is it for 1? Well, I need this to be 1 over here, to be a unit rate. So if I divide by 15 in both parts, I get 5 over 15 over 1. So my unit rate is 5/15, which I could reduce that to 1/3 over 1. That's my unit rate. So is it easy to find that one? It's easy to use any point that's easy to read on the graph to find the unit rate. So I could have used the point 30/10. I could have used this point, 30/10. Remember, this is X, this is Y. Y over X gives me my constant or my unit rate. So this would be 10 over 30, which is 1/3. So for 1 gallon, I'm going to get 1/3. Oh my gosh. Wow, is that easy to put on this graph? I'm going to pick another color here. For 1 gallon, wow, I'm only going to get 1/3. 1/3 of a minute, 20 seconds. Oh, like the water challenge. You dump a gallon of water over your head, it takes like 20 seconds, not even. That makes sense. Plot the unit graph. Oh, we did. I did this. I did eat. Plot the unit rate on the graph. Is the point on the line of this relationship? Yeah, it's on this black line. It's very, very hard to put it on there, but I can put it on there. I can put it on there. It's the point when X is 1. When X is 1. So for 1 gallon of water, I get 1/3 of a minute of time in the shower. Write the equation to represent the relationship between the number of gallons used and the length of the shower. Okay, so Y equals my constant of proportionality, 1/3 times X. Y equals 1/3 X. Or, since they used M for minutes, my minutes that I get is 1/3 times my gallons. Next page. Last one, number 2, example number 2. Your friend uses the equation cost is equal to 50p. Cost is equal to 50p to find the total cost of people entering the local amusement park. Create a table and record the cost of entering the amusement park for several different size groups of people. Okay, well, if no one goes to the park, I already started this, you don't have any cost. If one person goes to the park, You put a 1 here. 1 times 50 is 50. If 2 people go to the park, put a 2 there for P. 2 times 50, you get 100. If 3 people go to the park, it costs $150. So I can keep replacing my P many, many, many times, right? If 5 people go to the park, 5 times 50, 250. What if 10 people go to the park? 10 times 50 would be $500. Part B, is the cost of admission proportional to the amount of people entering the amusement park? Explain why or why not. Yes, it is proportional. There is a constant. There is a constant. It's $50 per, oh, I didn't put the 50 in. It's $50 per person. What is the unit rate? I just figured that out right here. And what does it represent in the context of this situation? The unit rate, K equals 50. It's $50 per person. Well, that was easy. $50 per person. Already answered that question. Letter D, sketch a graph to represent this relationship. Well, I started filling in the graph for us to save time. Sketch a graph. Okay, well, I had on my table 1 person cost $50, 2 people cost $100, 3 people cost $150, 5 people cost $250, 4 people, oh, I didn't have that on the table, 10 people would cost $500. I'm going to put some of those points on the graph. They look like they're going in a straight line if I continued that. What points must be on the graph of the line if the 2 quantities represented are proportional to each other? The 2 quantities are people and cost. Explain why and describe this point in the context of the problem. Well, I already explained the why. Why must 2 points, which I'm going to tell you what they are, be on this graph? Well, a graph must pass through the origin. So the first point I'm going to talk about is 0, 0. Because a graph must pass through the origin, and there has to be a constant unit rate. So the other point that has to be on here is 1 and the constant unit rate of 50. That point has to be on the graph. Otherwise, it wouldn't be a proportional relationship. That's why it's on there. So 0, 0, the context of this problem. Well, if 0 people go to the park, it costs $0. 0 people cost $0. And you have to have both zeros. 1 person costs $50. That's what the unit rate is. All proportional graphs have to have these 2 points. The line has to pass through the origin, 0, 0, I'm going to plot it, and 150, when x is 1. This is the unit rate right here, this point, 150. Would the point 5, 250 be on the graph? Yes. Oh, I didn't put it on there. 5, 250, let's put it on there. Yes, it would be on the graph. What does this point represent in the context of the people, of the context of this situation, rather? It means 5 people cost $250, right? 5 people cost $250. And that's it for today.